Welcome back, dear students, to the last video on the chapter database. And in this video, we are going to talk about the database users and the data integrity. Database users are essential in database systems since they are responsible for building, maintaining, using, and sending feedback for updates and upgrades of the system. The different category of database users we can have are we have the end user, first of all, which are the users who access the database for querying, updating, and generating reports as a function of the end user. They play an important role in the database system since they provide feedbacks to other category of users because the end user are the one making use of the system. So when there are errors or frequent changes that can be made on the database system, they are the one providing such feedback to other categories of users. We also have application developer, which are the users which write code to allow end users to interfere with the database system. So the application developer is the one in charge of writing the code that will enable user to use the GUI components and interact with the database system. This category of user need to be familiar with the DBMS in order to accomplish their duties. The most important, I will not say the most important, but one of the most important as well as the two above is the database administrator, a DBA. This is the person responsible for designing and managing the database system. And when it comes to advanced level ICT 796, students are frequently asked the function of a database administrator. He authorizes access to database, he monitors the use of the database, as well as he manages all the resources to support the use of the database system. Also, he is the one receiving the feedback from the end user and ensuring that the updates are made by the application developer. That's another function of database administrator. So these are some of the different users, the most important users when it comes to database system. And you as a student, you find yourself as an end user. Database integrity. When creating a database, attention needs to be given to data integrity and how to maintain it. Data integrity refers to the accuracy and consistency of stored data within a database. Very important. In this video, I'm going to use a DBMS in order to show you how some DBMS implement the database integrity. A good database will enforce data integrity whenever possible. Data integrity ensures that data remains intact and unchanged throughout its entire life cycle. All data in the database is traced and connected to other data. Every data is searchable and recoverable. That is what data integrity ensures within a DBMS. Having a well-defined and controlled data integrity system increases stability, performance, reusability, and maintainability. In the database, data integrity is divided into three types: entity integrity, referential integrity, and domain integrity. The first one, domain integrity. It states that all columns of a relational database are in a defined domain. It concerns the validity of entries for a given column. That is the domain. For those of you who do math, you know what I'm talking about. If you come to a function like the square root of x, you know that x cannot take a value less than 0. So that's the domain. And it's the same thing with the field. Every field are defined in a particular domain. It concerns the validity of entries for a given column. Selecting the appropriate data type for a column is the first step in maintaining domain integrity. Yes, and there are other steps such as setting appropriate constraints and rules to define the data format and or restricting the range of possible values. Let us go to Microsoft Access and see how this domain integrity works and how the database management system, through these different steps that are enabled, ensures that the data matches what the user wants. Okay, being in database, I will just use this example to show most of the ICT students with the errors they are always committing. When you open Microsoft Access, as you can see, you do not come and double click directly here, no, because You are fond of double clicking when you need to click. When you want to create a database, you simply click once. Then you are going to have this that will come up. You simply write the name of the database. After writing the name of the database, you come and click on this folder where it brings you to this place where you can now select the path where you want to save the database. In this case, I want to save it on desktop and I want to save it as what? Data integrity test. Yes, that is what we have. From there now, you start the extension has been added, ACCDB, Access Database. So I click now on Create. Once I always create my database in Microsoft Access, as I always tell my students, the first thing is to close this existing table so that you have your fresh database now and you perform the function normally. Yeah, we are supposed to see how domain integrity is being maintained. So let me go and create a table. Do not worry, dear students, because you are going to have a practical on this Microsoft Access with all these different strategies, how to create a table and so on. So to create a table, you come on create. From there, you simply take table design. From there now, you have your fields and your data type. So first of all, let me enter age. Then I enter name. Then I enter. They say if you use a reserved word, you may receive an error when referring to this field. No problem. I can enter which field again. Let me say height. Good. Now, we know that age is a number. So I change the data type and I make it to be a number. The height also is a float, that is a real number. So I take number, then I come here and I modify the type and I make sure that it should be a double, as you can see, or you can simply take decimal. I prefer double for double precision. Then for the name, there are some systems that make sure that what your name should not be more than 10 characters. So at this level, I will simply come on this field and I change 255, which is the default, and I put it to 10 characters. You can also specify the format mask. It depends on you. Input mask depends on you. Decide on the type of input you want, and so on and so forth. These are the different ways by which you can reinforce the validation, the domain integrity. Let us just use what we have here. Good. So when I create, they say you have to save first of all. So I will say table one. Okay. An error that many students always do not take note of. When you are creating a table, there are some tables that do not need primary keys. And in such a way, when you create a table and there's no primary key, you always have this problem where they say there is no primary key. And when they ask you, do you want a primary key? You say no, because if you wanted the primary key, you would have put it. In other cases, you might have forgotten, but primary key is always an essential point when you are creating a table. So I will say no, because I just want to test. So now the H is a number. If I enter G, when I press enter, what did they say? The value you enter does not match the number data type in this column. So it's like this is a domain integrity. It restricts me from entering numbers because we know that there are some users that when you are filling a particular form online, a place where you're only supposed to enter numbers, some are entering text, and at that level you have an error. And if your software is not robust, it can crash. So that's how we enable domain integrity by specifying such rules. So if I enter now 2045, everything is okay. For the name, you specify that it should be less than 10. So let me say byte by byte. You see that when I want to enter TE, it does not take. Simply because what? This is 4 characters, this is 2, that makes 8. Space is also considered as a character. But if I don't put the space, it will take the byte by byte. If I enter any letter again, it will not go. If I come here, I see that this is array, so I can enter 4.5. Remember that h was an integer, so if I enter, for example, 5.7, it rounds up directly, so that's domain integrity. If it's a field where it is integer and you enter a real, it will round. So if I enter 2.01, it takes it as 2. Whereas if I come here and I put 2.01, it considers it normally without any problem. And that is how domain integrity is being enforced, dear students. We move to the other type of data integrity, which is entity integrity. And it states that each tuple, that is each record of a relational database, must have a unique non-null primary key value. It concerns the uniqueness of every record of a given database table. To ensure this integrity rule, a good key fields should be selected among the different attributes of a relation. So let us see how to enable entity integrity. So back to this one, if I close this table 1 and I create a new table, I'm going to create a new table and I'm going to show you something. I'm sorry, supposed to create table design. Yes, so I will say student ID, good. Then student name, age, and address. Or let me say series. That is the series the student is offering. And I make sure that series consists only of 2 characters because A1, A2, and so on, only of 2 characters. Then I put this as my primary key, as you can see. There are 2 ways you can put a primary key. Either you select the field, then you click on primary key, or you can right click on it, you select primary key. Everything is okay. So now I click there and I save. I put the name student. Everything is okay. So now if I want to fill the values now, I can still click here. I take datasheet view or I come and I click here directly. I can fill. So if I enter ST001, I enter. Then the series S4. When I want to enter again, it does not take. So if I enter the same student ID again, when I press enter, I fill, I fill. Is that it's waiting the end. When I enter now, what does it say? The changes you requested to the table were not successful because they will create duplicate values in the index, primary key, or relationship. Change the data in the field or fields that contain duplicate data. Remove the index or redefine the index to permit duplicate entries and try again. Okay, so I will simply come here. Remember that when you're having such error, if you click anywhere, you come and you modify it too, everything is okay. Even if I come here, I put FSHSG 15 S4, there is no error. Everything can be the same so far as this particular field is different. Everything is okay because that's why we say the primary key must contain different values which are not null. Let us see the case of a null entry. So if I enter something, let me say 17, I enter A4. When I press enter, it says you must enter a value for the student ID field, as you can see. It says student the student ID because this is the primary key and it's from the table student. That one is just for you to see that we cannot have a null value for the primary key. So I can enter now ST00. If I enter 2, I come down, error. I need to change the value. If I enter 1, error, I need to change. So I can put even 5. Everything is okay. So that's how the database enables the entity integrity because you have specified that this particular field is your primary key. Now, in case you have a field composed of a primary key, how do you do that on Microsoft Access? If I want to create a field, let me say table design, good. Let me say customer ID, then product ID, that is, a customer has can order many product and a product can be ordered by many customers. Good, let me say quantity. Good, everything is okay. So these two are the primary keys. If you come here, you put primary key. When you will come down and put primary key, the primary key will move down. If you come back up, some students always found error at that level. When you come down, you put a shift. So for you to select two primary key, you can just come. You cannot select like this. No. If you want to put a 2 as primary key, you need to come at this level where the arrow is like this. Then you select the 2 now and you put them as a primary key so that they are now your pair of composite key. So you save the table. Let me save it as order. Good. So now if I enter the customer ID CU01, product ID PRD01, the quantity 56. I enter CU01 again, PRD02. You see that customer ID accept repeated column. You see that it accepts there's no redundancy here because our primary key is a combination of this man and this man. So now here I can have CU02 and then I have PRD01. You see that this is different, this is the same. 1 1, 1 2, 2 1, they are not the same. But if you enter the same values for both, that is CU01, PRD01, and you enter, for example, 63, error. The changes you requested to the table were not successful because they will create duplicate. Because the primary key is the component, the DBMS know that what? Your composite key here is a combination of this and this. So when you read this and this as one, they should not be the same as is the case here and here. If I change this and I put 2, you will still have the same error. So I hope now that with this you understand what the entity integrity is all about, because these are such errors that many students always have when it comes to practical. Even those of you that are using SQL or your Access or Microsoft Access, these are such errors that you can equally have. We move to the other type of integrity. The last and most important one is the referential integrity, and it states that the foreign key value can either be null or refer to a primary key value of the table it references. This constraint ensures that the relationship between tables in database remains accurate. I love this particular integrity because sorry, it enables their data. In fact, I think that this it is referential integrity is the one enabling all these three, as you can see. Let us move to access. In fact, let me explain again. This integrity type ensures that what the foreign key values you have can either be null or contain a value that exists in the table containing the primary key it references. Let us look at an example for that. Okay, being on access, let me close this. Okay, no. So let me change this one and put 3. All is good and I close. Let me even delete all of them. Delete, yes. Delete, yes. Delete, yes. So now let me create 2 tables for you to see something. Sorry, create table design, teacher ID, teacher name, qualification. Good. This is my primary key. I think we are good to go. Yes. Teacher. So let me say T001. I'll just put 3. So let me say byte. It represents me. Master's degree. T002. I can say Mr. Jesper. Masters T003. Mr. Ngeti. Ediplec. Good. Let me add another one. We say Madame this a bachelor's degree. That is what we have. So I save this particular one. Then I create another one. Oh, error. Let me say subject code. Subject title. Coefficient. I think all is good. This is my primary key. And now let me just show you something, dear students, for you who don't know. When you want to create, if I save this and I say subject, because it's not show you that, when you take OK and you say, do you want to create a primary key? When you say yes, it comes and creates a primary key for you. So it does not attribute the primary key to the right field. It will create a particular field and tell you that it's the primary key. In that case, you simply, if you are already at this level and you see, because it's at this level, that many students always realize that the primary key has been added. And when you ask such students, they will say, it came alone, it came alone, it came alone. Whereas they are the one who accepted the database management system to give them a primary key. Remember that in first normal form, if a table is not in first normal form because of the uniqueness, then a particular field is created and each entries are attributed. A particular field is created to ensure the uniqueness of that, where it contains each value for a record, and that's the same thing the DBMS is doing. So when you're already at this level and you want to cancel that, you simply come on the view, or you can right click here and you take design view, because for database for ICT students, these are the only 2 views you need: design database, design datasheet, design datasheet. It is true that we shall be solving GC June 2019. You are going to look at a 3rd view that you need to know, but for now, design datasheet. So when you are at this level, you come to datasheet and you right click here, You simply take delete rows. Yes, you delete them. You put your hide primary key and you save. So when we come here now, we know that what one subject can be taught by many teachers. So subject has cardinality one and teacher has cardinality many. In that case, the primary key of subject should be inside teacher. So first of all, let me put the subject code. I'm going to put 795, the beast, computer science, for 5, 796, ICT, for 4, 775, for that Q, for 5. Let me save this. So since we know that subject cardinality 1, teacher cardinality many, so I will just come and add a field. I will just come on this view, then I add a subject code. Good. Yes. So the subject code is byte for byte 795, 795. Oh, sorry, 795, 775. Let me say this is 796. Good. I save now. So now, when I come at this particular, let me close this first of all. When I come on database 2, I take relationship. I select these two tables. You see that what teacher has a primary key, teacher ID, subject has primary key, uh, subject code, and that subject code is also present here. So when you want to create a relationship in Microsoft Access, you simply carry this. You can do that through SQL. We are going to see that, or you can just carry this primary key and you put it on this foreign key. As you see this small box, very, very important. When you click on it, you allow this and this. Meaning that what? When a particular record will be deleted in the table where the primary key is going to do the same thing for the related records. So now let us see a case where a student does not enforce refresh integrity. When you create such, first of all, you see that there is no cardinality. In that case, let us look at what we are having. Subject, teacher. Our primary key is at the level, our relationship is at the level of subject code. Now, if I enter a new teacher, let me say T005, let me say Mr. Njoya, my man, 79, let me say 796. Then I come on Madam Helindis, who is a powerful physics teacher. I think the subject code for physics is 785. So let me say 785. And I save. When I close, there is no problem. Look at something. You see that under subject code, there is a particular subject code 785 which does not exist at one of the subject code here, but it exists inside teacher. Why does Microsoft Access allow that? It is simply because we did not enforce the referential integrity. Let me change it back and I put 796 and I save. Same thing here. I close the two tables. I come on the relationship, so the relationship even has been deleted. When you add, okay, that's the relationship that is being there. So when I double click on the relationship now and I enforce referential integrity, I do that, I cascade the update and the delete, and I take, okay, so that the cardinalities are there. So one subject can be taught by many teachers, the infinity sign. In ER model, it is M or N. So now, if I open back these two tables, if I come on Madame Helindis again, and I put 785, when I press enter, it says you cannot add or change a record because a related record is required in the table subject. So I cannot put this particular subject code because it does not exist in the table subject. So for you to do that, you must come here. First of all, I say 785. Remember that in the table teacher, it has not been changed because when I click anywhere, it refuses. It just refuses. It will refuse until I put back something present like 796. Now it is okay. I come to subject 785. Physics, coefficient 5, I save. When you come under teacher, if I change this now and put 785, everything is now okay. There is no problem. So it's not that is then how refresh integrity works. It works in such a way that what the value, let me say I have a new teacher, T006. Let me say Mr. 14, then bachelor's degree. And he is doing a subject, let me say chemistry. Chemistry has not been decided, so I allow it blank. So it's that it can be blank. But for the foreign key, as we saw the integrity, the primary key cannot be known. Because if I enter a new student like Mr. Zonde, I enter, for example, a bachelor's degree, the subject code is not there. But when I want to press enter, it's saying you must enter a value for teacher ID because it's the primary key. But you see that there was no error for foreign key because the foreign key can be null. We saw that when we were answering the Sawos regional mock 25, when we saw the property of foreign key. We saw that one, foreign key can contain null values. Two, foreign keys references the primary key and it can contain duplicate as you can see here and here. These two are duplicate as you can see. But if I come here and I put 700 1 that already exists, error. So the primary key cannot contain duplicate, it cannot contain null values, and the foreign key must always references. So some of you might not always have this error of referential integrity because in the relationship you are not enforcing referential integrity, and that's the error you have. So now let us see something. Remember that I enforce referential integrity and I cascaded updated records and cascaded update related fields and deleted related records. Okay. Now, let me show you something also here that they are telling us that it is a one-to-many relationship. Good. So now, if I come on that subject and I delete, for example, further pew, let me say I want to delete this record. So if I delete it, they say relationship that specify cascading delete are about to cause one record in this table along with related records in the related table to be deleted. Let me close first of all. Remember, in the table teacher, there is one teacher, Mr. Getty, who is teaching further pew. So when I delete this particular one and I delete this subject, I think yes, inside the table teacher, as you can see, deleted. So there was a teacher that was teaching a particular subject that has been deleted. And if I come back and I put 775, let me say further pew, coefficient 5, and I save inside the table teacher, it does not come again. It is over because it shows that what it has been deleted. Now let us see for the case of an update. Let me say ICT is instead you cannot first of all update the primary key. It will not go because it is delete and put by 8 and you save. When you come under teacher 796, you see Mr. Njoya 798 has been updated as you can see. If I come on computer science and I instead of 795, I put the 790 and I save, all the teacher with 795 becomes 790. So that is why enforcing information integrity enables you, it eliminates already the problem of how can I say it? It eliminates the problem of update anomaly because as you saw, I updated the subject for computer science. It does the same thing here rather than doing one by one that you go and do one by one. No. Delete anomaly. First of all, if I come on Madame Helene this and I delete Madame Helene this, you see that Madame Helene is the only instance of physics. When I delete her record, yes, inside the table subject, physics is still present. So with this, deletion anomaly is no more there. When it comes to insertion anomaly, if I want to insert a new subject, I do not need to insert a particular teacher for that. As well as I insert a new teacher who did not have a particular subject already, there was no error with that. So that is how powerful the integrity enables the data in the database to be consistent, dear students. So we move back to our notes. I hope this practical part enables you to better understand the different types of integrity. Now, if referential integrity is not enforced, like what we saw, we will have a situation where a foreign key value has no matching primary key value in the primary table, as we saw that. And this results in what we call an orphaned record. An orphaned record, remember, an orphaned record and an orphaned record, they are the same, is one whose foreign key value references no value from the primary key field of the table it references. It is also known as a dangling record. So when referential integrity is not enforced, majority of you might be doing your practicals and due to the fact that referential integrity is not enforced, the output of your query might not always be correct. So you will run your queries, no error will be given to you and you will think that you are right. Whereas when implementing a relationship, everything was not okay. And I think relationship, as we saw in the previous video, comes at the conceptual level. That is the definition of an orphan record. To ensure that there is no F1 record, we need to enforce referential integrity. Referential integrity deprives its users from adding record to a related table if there is no associated record in the primary key table. We saw that. So it prevents the addition of a record to a table that contains a foreign key unless a corresponding key in the linked table. We saw that one. Changing values in the primary key table that result to orphan record in the related table. We saw that when we change, the change is being updated in the other table. Deleting record from a primary table if there are matching related records. We saw that if we try delete, but that's the case for Microsoft Access. Other DBMS have their own way of implementing the referential integrity. I hope you enjoyed watching this video and you understood more about data integrity and database users for both 795 and 796 students. Do not forget to like, to subscribe, and to share for our community to grow. And see you in our last video where we shall be talking about the different types of files we have in the database. Thank you and see you in the next video.